Shreya Shah from IT department, and last session of MPMC we have seen about the AVR interrupts. We have seen the basics of AVR interrupts, and now in today's session we are going to study how to programming the interrupts using assembly language. Right? So let's start with the topic, that is programming interrupts in assembly language. Now, so here we will see an example. Last session we have studied what are the different steps for executing an interrupt, what are the different interrupts which we have in Atmega 32, and now based on the timer interrupts we will see an examples. So first example, here the program has been given to us, and the statement is assume that port C is connected to 8 switches and port D to 8 LEDs. Use timer 0 to generate a square wave on a pin port V.5, while at the same time data is being transferred from port C to port D. Right? That means what we need to here, port C has 8 switches, so port C will work as an input and port D is connected with the 8 LEDs. So based on the switches pressed on port C, the output should be displayed on the port D, which is on the LED. So port D, that is our output. Now on this particular task, the second task which we are going to study, that is PB5, that is port B fifth bit, we need to generate a square wave, right? And we need to use the timer 0 for an interrupt purpose. Now let's see the solution of this. So in this first, while executing an interrupt, here we are making the use of the addresses, right, for the interrupt vector table. So as we have discussed in the steps for executing an interrupt, so what does the interrupt will do? So whenever the interrupt is called, it will go into the interrupt vector table where the address is found, and then it will jump to that particular address where that particular interrupt service routine has been written over here. Alright. So what we will do is, in the interrupt service routine, we will write the program that is based on the square wave generation of PV5. Right? And whenever the interrupt generates, it will generate the square wave. And if the interrupt is not generated during at that particular time, the data from port C to port D based on the switch pressed, that is transferred to the LEDs. Right? So let's see the solution. So first we have include the file of atmega 32, that is dot include m32def.inc. Now here we need to define a reset. So reset interrupt has an address that is 0x00. So that is dot org 0x0. That means our program will start from 0x0. Then it will jump to the main program where the main program has been written over uh, at the sum address. Right? Now here we are using the timer 0 interrupt overflow interrupt. So timer 0 overflow having the address that is 0x16. So dot org 0x16 where they need to jump at the interrupt service routine. So in the third line, you can see that dot org 0x16 where 0x16 is the address for the timer 0 overflow flag, right? And in that particular, we need to jump at the label which is having the ISR. So jump JMT TOV TO underscore OV underscore ISR. So this is the label which we have given for the interrupt service. Right? Now we will write the main program. Now in the main program we will do all the initialization. Right? Here we need to store the addresses. So we need to initialize first of all the stack. So as you can see in the main program, first 5 lines that has been discussed for the stack pointer where we need to store the address. So LDI R20, H where a high that is the ending address of the RAM, and that particular address is passed to the SPA, that is stack pointer higher byte. And LDI R20, low, that is the low address of RAM, and that it is passed to the SPL, that is the stack pointer lower byte. Right? Now what we need to monitor each and every time, we need to monitor the interrupt flag of timer 0, that is in TIMSK register. So first we will monitor the TOIE0, that is timer interrupt flag enable, which is in the TIMSK register. Right? So based on this two instruction, we are monitoring this flag. Now we are generating the square wave on the port B fifth bit. So we have a output port B fifth bit. So here we have declared SBI DDRB, 5. That means port B fifth bit has been set to 1, so that will work as a output. Now, after monitoring this interrupt, we will enable the interrupt using the instruction SEI. So SEI will enable the interrupt, and it will check either interrupt request has been generated or not, right? If interrupt request is generated, it will jump to the ISR table. Otherwise it will jump to otherwise it will jump to the main program itself. Now in the main program itself, we are initializing all the values related to timer as well as related to the input output ports. So again we are again in the as you can see, after SK instruction, LDI R20 minus 32. So minus 32 has been loaded for the timer, right? So 32 clocks back counting will be happen. So minus 32 is loaded in TC and T0. Then TCCR0, here timer 0 is working. We are assuming that timer 0 is working in the normal mode with no pre-scaling. So in TCCR0, 0x01 is loaded using these two LDI and out instruction. And then port C is working as an input and port D is working as an output. So port C and port D we are declaring as the input and output, making DDR C as 0x00 and DDR D as 0xFF. Right. So all the initializations related to the ports as well as the timer has been done in the main program. Right. Now there are two programs. First, in the main program there is a data transfer from port C to port D. So as in the here loop, as you can see, the data from pin C has been loaded to the register using LDI instruction, and that particular data is transferred to the port D using the out instruction. So continuously that particular data transferring will be done in the main program, right? Whenever the request is generated, it will jump to the interrupt service routine where the next program of timer for generating a square wave on port B fifth bit that is written. So what we need to do is, first we need to take ISR, right? On the ISR, what we need to just input the data from the port B. So from port B, we are taking the data into the register, right? Then we have what we need to toggle the fifth bit, that is square wave. So 0 1 0 1. We need to toggle every time the fifth bit of the port B. So here, whenever we need to toggle only particular bit, what we are doing is we are XORing that operation with the particular bit with 1. Right? So whenever you are making the fifth bit 1 and rest all the bits will be 0, the data will be 0x20. Right? So here we are taking the register 0x20 in register 17, and whatever data comes from the port B, that is XOR with the R17 data. So EOR, R16 and R17, and the data in the R16 will be again displayed to port B using the out instruction. So out port B comma R16, right? And at last what we need to do is we need to again load the counter. So load the counter with the value minus 32, which we are loading the main program, right? And then it is given to the TC and T0. So these will be done with the help of interrupt. So this is how the program can be written for the timer, which we have seen in the programming language, which using this interrupts. Clear? Now, similarly, next example we are seeing, here we are using the two timers. So use timer 0 and timer 1 interrupts simultaneously to generate square waves on PB1, that is port B first bit, and port B seventh bit respectively, and while the data is being transferred from port C to port D. So as we have discussed in the first program, similarly all those things which we have written for the first program, that has should be written in that for the timer 0 as well as for timer 1, right? And the main program will be same as it is, that is initialization of all the ports as input and output, as well as the initialization of the timer 0 and timer 1, right? So as you can see here, we have taken three .org. First, that is for reset. Second, .org 0x12, that is timer 1 overflow flag, and 0.org 0x16, that shows that the timer 0 overflow flag. Clear? Now, in the main program, we have initialized first of all the stack. Then we have set the first bit of PB port B and seventh bit of port B as output port. So as using SBI instruction DDRB1 and SBI DDRB7, we are making these ports as a output port. Then we are setting the interrupt, right, using the TOI flag of 0 and 1 as a 1, right, and we are setting this interrupt using the instruction SCA, right. Then when we have load the TCNT0, TCCR0, then timer 1, TCNT1L, 1H, and timer then TCCR1B and TCCR1A. Right. So here we have loaded all the values, and last we have make port C and port D. Port C as the input port and port D as the output port. Using this DDRC is equal to 0x00 and DDRD is equal to 0xF. Okay. So this is all the initialization in the main program. Now in the main program, we need to transfer the data from port C to port D. So the program which we have discussed earlier in the earlier example, that is same for this here loop, right? Now there will be a two ISR. First ISR for timer 0 and second ISR for timer 1. So as you can see, the timer 0, what we need to do is we need to toggle the PV1. So first bit will be toggled. So it is as you can see, first bit is 1 and rest all the bits will 0. So the data in R16 will be taken from port B, right? And it is XOR with 0x02, which has been stored in R17. So that program has been written in this first ISR, and in second ISR we need to toggle last bit, that is PV 7th bit. So first again we will take the data, and after taking the data, what we will do, we will toggle, we will XOR the operation with the 80, right? So 80 as we are making the MSB1, right, for toggling, that is PV7. So same program will be written for the timer 1 itself, and again we will load the count here. So that is all about the example 2, in which we have used the two timers, that is timer 0 and timer 1 for as a interrupt. Right. Now let's talk about the example 3. So in example 3, the statement has been given as port A counts up every time timer 1 overflows. It overflows once per second. A pulse is fed to timer 0, where timer 0 is used as a counter and counts up. Whenever the counter reaches 200, it will toggle the pin PD6. So this program has been written for timer 1 and timer 0 again. Right? At timer 1 will check either port A is counting maximum, and when it overflows, right, it will shows the overflow TOIE1 flag, that will be overflow. And the timer 0 will continue the counting up the counter up to 200, and whenever it reaches the 200, it will toggle the port B 6th bit. So again we have initialized all the values depending on our timers. Timer 1, that is 0x12, and timer 0, that is 0x16. Right. Now in the main program, we have initialized all the values. That is, first we have initialized the stack pointer. Second, we are giving the input output port working as an input output port, and third we are loading the values for the timers, that is timer 0, TCNT0, TCCR0, and for the rest and for same for the timer 1, that is TCNT1H, TCNT1L, and based on the counting. Right. Now in the here program, what we need to do is we need to continuously transfer the data from port C to port D. The same program will run over here from the previous programs. Now in the first service routine for the timer 0. So what does the timer 0 will do? It will count up to 200, right? And whenever the 200 count will occur at that, and the timer overflows, so the data from the port B, right, port PB6 will be toggled. So sixth bit is toggled. So sixth bit, when we make the sixth bit 1, so the data will be 0x40. So we are XORing the port B data with 0x40. Clear? Similarly, for the timer 1, what does the timer 1 do? So timer 1 will count up to maximum value, and whenever the data will port A, whatever the data will count, that data will send to a port A, right? So what is doing, we are incrementing every timer, so incrementing R80, then that particular incremented value is given to port A, and this increment will done up to the maximum value, which is up to 255. Clear? So this is the example number 3. Again we are using here the two timers, that is timer 0 and timer 1. right? Now, next that is how to use timer for the compare match and the flag entry. So sometimes a task should be done periodically as in the previous examples. The programs can be written using the CTC mode. In the last program, we have used all the timers in the normal mode. So we are monitoring the timer overflow flag. Now we are using this compare mode flag. So we will use the output compare flag for the comparison, right? So to do so, whatever we are loading with TC and T0, that should be loaded in OCR register, and TC and T register will be loaded with 0x00, right? So when the content of TC and T matches with OCR, the OCR flag is set, which causes compare match interrupt to occur, right? So similarly, whatever the CTC mode which we have discussed in the timer, same CTC mode will be worked with the help of interrupt, and in the TIMSK register, we will monitor OCIE flag, that is output compare interrupt flag, right? And with the help of this, we are using the programming in the CTC. Now, let's see say same example using this CTC mode, right? So in the CTC mode, what we are doing, we are loading the counter right with the less one which we have occurred. So as you can see, that means the OCRO, that is equal to 40 minus 1, that is 19. So the same program will occur right here in place of TC and T0. This 39 will be loaded in OCR0, right? And in the main in the ISR, we are monitoring which flag, that is OCIEO flag. So the OCIEO flag over here will be set and will be monitored each and every time when the interrupt will be enabled, right? So that's all for the today's session, right? Here we have completed the programming of interrupts in assembly language, right? And now next in the next session we will see how to programming the interrupts in the C language, right? So that's all for the today's session. Thank you for watching.